Jimmy here with another lesson about some helicopter flight. Today's lesson we're going to talk about moisture. But did you know that the very first person ever rescued by a helicopter was rescued in 1944? They were lost at sea or out to sea somewhere. But since that time, over 3 million people have been rescued, all because of helicopters. So thank you to all the helicopter pilots out there, and thank you to those watching, and thank you to me for being a helicopter pilot. And maybe someday I can rescue somebody too. But moisture. Moisture is very important. The weather is actually very, very dependent on moisture. When the air is dry, weather is usually pretty good. When the air is cold, well, not so good. It can even get pretty severe in some instances. This particular lesson looks at some of the properties and characteristics of moisture and how important it is for us to know what to do and how our aircraft reacts in these and the safe operations of flying through different types of moisture and moisture in general. Every type of weather exchange that happens because of heat. It's a heat exchange. And there are 3 types of moisture here that we have with us. There's solid, liquid, and gas. And as water changes form, it takes heat, a heat exchange. And as I said, every physical process every physical weather process is because of exchange of heat. There are several different ways that this happens, especially for moisture. One is evaporation. Evaporation is what happens to a liquid, and it just goes into an invisible water vapor. The opposite of that would be condensation, where it's your invisible water vapor condenses into a liquid, which you will oftentimes see on a soda can left out in the sun, or maybe your water bottle gets it. I drink a lot of water, that happens. The other thing is sublimation, and it goes from ice directly to water vapor. You might actually notice this with dry ice. Dry ice doesn't actually melt, it just goes from solid to a vapor right away. Another way that that happens to moisture or water is melting ice to water, and that's pretty direct. You can watch ice melt if you want to. And of course the vice versa is freezing water ice, and of course if you really want to watch water freeze to ice, please go ahead. But the important thing to realize is that there is 2 main ways that water is actually added to the atmosphere and moisture is added to the atmosphere. That's through evaporation and sublimation. Now, there are several different ways that we calculate moisture. And because moisture is so important to us in the industry, we have, or not we, I guess, but scientists have taken some time to make some terms that everybody should probably know. First is humidity. What humidity is just a general term for the moisture in the air. Now, if we want to get a little bit more specific, you could say, oh, it's really hot and muggy outside. Well, that's because it's very humid outside. I come from Idaho. It's very, very dry. Not very humid at all. But where I'm currently at in Oregon, it gets pretty humid, and I can definitely tell the difference. Now, to kind of give us an idea of how much humidity is in the air, we call that relative humidity. Now, relative humidity, what that tells us is it tells the amount of moisture that's in the air, or the actual amount that's in the air compared to the total amount that could be present at a certain temperature. So, the warmer the air is, the more moisture that the air can hold. The colder the air is, the less moisture that the air can hold. Now, the dew point is the point at which the air becomes saturated, and where it can't hold any more water. 100% of the moisture is all it can hold. Now, this doesn't necessarily mean that we'll be able to, it'll rain. It doesn't mean it's going to rain. But what it does mean is that the moisture will then become visible. And moisture becomes visible in several different ways. But as the air cools to a saturation point, the invisible moisture in the air, like I said, becomes visible. And it becomes visible in several different ways. Clouds, fog, dew, frost, any of those ways, you wake up in the morning, you see clouds, you see some fog across the airport, that's all because of moisture. It's a visible moisture that we've been able to, the air has become saturated because of this. Now, dew point can tell us a lot of good information. If we take a look at our weather reports as pilots, we might see that temperature is 17 degrees and the dew point is 15 degrees. This usually tells us what the temperature is outside air temperature, and this usually tells us our dew point. Now our dew point, as these two get closer and closer, that just tells us a couple things. One, it tells us that the weather can get worse. Two, it tells us that we could be getting visible moisture as it gets from 15 to 17. And that's when we really have to be careful, because with moisture and higher altitudes, we could get icing problems on our aircraft, and it could make things very difficult for us to fly. So what's really great is as we can actually watch the temperature and the dew point and kind of just give us a good idea of what might happen in the very near future. Now, clouds are some of the most fascinating forms of visible moisture. What's really unique about clouds is that they have to have very small droplet. They have to have something to form. So they have a small condensing nuclei type thing where droplets of water can condense and collect on, and then the cloud builds from that. Now, clouds and fog will usually form as soon as the air becomes saturated or the dew point is reached. It's very important that we understand, again, the difference between the temperature and the dew point, because then we can kind of anticipate when these clouds might form, and sometimes even over certain areas what types of clouds will form. And then, of course, when these clouds form and they have enough moisture in them, we can get some precipitation. Precipitation can be in the form of rain, snow, hail, ice pellets, ice crystals. All these are different types of precipitation, and not all of them are good. Flying in rain, yeah, it's not that big of a deal, especially for helicopter pilots when we're closer to the ground. But when we get, say, ice pellets or hail at the surface, that's a pretty good indication of a temperature inversion or freezing rain at a higher altitude, which might tell us we might not want to fly too high. Now, frost can be particularly dangerous for aircraft in general. As a matter of fact, of all the different types of icing that can occur on an aircraft, frost is by far the most dangerous type of icing that there is. And it can happen anytime. Usually someone will go out on a cold morning and there'll be frost on the wings or perhaps even on the blades, and it's very important that we get all that cleaned off, because you can greatly reduce the amount of lift that those wings or blades produce. So moisture does play a huge point in everything that we do, and it's very important that we understand how it works and the different types, and maybe even how we can keep an eye out for it. As always, if you have any questions or comments, please leave them below, and have a good night.